All right, back in the 1930s when I was going to school, we had this system where we had two captains and they picked teams. So I've got two captains right here. We've got rational numbers and irrational numbers. They're going to play a game of dodgeball. Irrational numbers has the first pick. It'll be interesting to see what they do as far as what costume they wear, because the cube root of 30, that's a pretty small number, but if we were to expand that out to what it actually looks like, be a much bigger number. But cube root of 30 is going to play for the irrational team, and it's the rational numbers pick, and they're going to have to choose carefully. I think that 8 will be the first number that comes off the board for the rational numbers. So 8, we know that rational means, or hopefully we know that rational means integer over integer, but if you look at that number 8 right there, there is no integer on the bottom. We can always put a 1 on the bottom, make it 8 over 1. The irrational numbers, they pick next. They got first pick, they get third pick. Some people say that's not fair, that rational should get the second and third pick. But life isn't fair, kids, so deal with it. Irrational number is going to pick square root of 2. The square root of 2, there is no square root. You can't multiply two factors that are the same together to get 2, so therefore it's irrational. Rational is up next. They're going to choose the square root of 0. So yeah, it's similar to the square root of 2 in that there's a square root, but you can actually find the square root of 0. 0 times 0 is 0. With the fifth pick, the irrational examples are going to choose 7 plus the square root of 5. Deceptive, because the 7 here is just like 8, it's a whole number, but as soon as you add an irrational number to it, this whole value, the sum of it, is going to become irrational. Letter F is going to be chosen by the rational examples. Very deceptive again. One deception calls for another. The square root of 7 squared means you're multiplying the square root of 7 times the square root of 7, which actually equals 7. Let me show you what I mean by that. If I had the square root of 9 times the square root of 9, we know that the square root of 9 is 3, and we know that the square root of 9 is also 3. 3 times 3, therefore, will equal 9. So, yeah, you get 9. Makes sense that the square root of 7 times the square root of 7 is 7. The next pick, the fourth pick for the irrational team, is going to be simply negative 3 pi. As soon as they see pi, they know they want that player on their team. Pi is an irrational number. And rational numbers, again, is going to follow suit with an easy rational number. As soon as we see that it repeats, it's a rational number, because rational, I'll give you a basic example. 1/3. We take 1/3. The 1 will go in the house. The 3 stays outside. We're slicing 1 into 3 pieces. 3 goes into 10 3 times. You subtract. You bring down. And again, it goes in 3 times. You can see it's repeating. And so this number, 0.33333333333, it was born from 1 over 3. That's its parent right over there. Its parent, it's 1 and the 3. And that, of course, is an integer. And that, of course, is an integer. So it's an integer over an integer. And since this number is the same as that, anything that repeats will be rational. Irrational gets to pick next, and they're going to go with square root of 16 over square root of 10. Again, a little bit deceptive, because the square root of 16 would be rational, but the denominator is not rational. Square root of 10 is not a rational number, so that would be irrational, and that leaves rational with the last one, which looks like it wouldn't be rational again, because 4/10 isn't an integer, and 8/10 isn't an integer. But if we multiply the numerator and denominator by 10, it would actually make it 4 over 8. Which both of those would be integers. All right, one other thing that's is going to come up on the Google form for today. Working in sports, we're not going to have to answer questions about this, but this is called a Venn diagram. I think that this is helpful for you to understand where the question is going. As you look at the Venn diagram here in pink, this is as specific as you get. Jason Tatum is on the Celtics, but at the same time, you could go all the way up to this top category. Jason Tatum also works in pro sports. He's on the Celtics, he's in the NBA, he's a pro athlete, and he works in sports. If you look at this one right here, this is more general. Roger Goodell, he's the commissioner of the NFL. He is not a pro athlete. He's not in the NBA, and thank God he's not on the Celtics. And, you can tell Patrick Mahomes, all right, he's a pro athlete. He's in the NBA. If you look at Giannis here in purple, he fulfills the yellow category. He also works in sports, but he's not on the Celtics, so he doesn't get in that category. That's kind of the way it works. And then you might have an example of something that's not in pro sports. Bieber fever is not in pro sports. Another example, again, more specific, is right down here. Reese's. That's a type of peanut butter, but Reese's is also a chocolate, it's a candy, it's a junk food. Whereas Oreos might not be the best example because maybe it fills chocolate. Let's cross out Oreos. Let's forget that ever existed. Let's put Cheez-Its in here, huh? Can we go Cheez-Its? Cheez-It. And just imagine that this is green. But Cheez-Its would be a junk food that isn't a candy, that isn't a chocolate, that doesn't contain peanut butter. And then over here we have our healthy foods, the carrots. Finally, we have the math connection, right? The most general example would be rational numbers. Everything that you see here is rational. Let's go to 16, 0, and -7. But integers are only the whole numbers and their opposites. So you see that 0.4 repeating is considered to be not an integer, but -7 is an integer and is rational. You look at the natural numbers here. The square root of 16 is 4. Everything else on this page, though, is not a natural number. Natural numbers, by the way, that's what Big Bird taught you if you ever watched Sesame Street. They're just the counting numbers, like 1, 2, 3, 4, 5, 6, and so on. It doesn't include 0, it does not include negatives, and it does not include fractions. And finally, the opposite of rational is irrational. The main ones that we study here in 8th grade are square roots that aren't perfect or cube roots that aren't perfect, and numbers, of course, like pi.